Hello everyone, my name is Carl. Welcome to my workshop and welcome to my YouTube channel. This is going to be episode 10 of the Harrison Mill Restoration series, and in this video we're going to be cracking on with the nut housing, the cast iron nut housing that we made. We're going to marry up the nut housing with the bronze nut that we made earlier on, and we're going to be drilling the holes on the PCD, 3.625 inch PCD, at 120 degree spacing for the mounting bolts. I was hoping that I would get a little bit further than I actually do in this episode, but unfortunately time was against me and I didn't get as far as I would like to have done, but you'll see anyway how far we get. So without further ado, let's crack on and we'll get on and get these holes drilled. So before we go over to the mill drill and start putting these holes in on this PCD, I just want to talk about a small design change that I intend to embody on the new housing. Now obviously this is the old one with this big broken out section here. This is a quarter 20, or the remains of a quarter 20 thread that was here for the anti-rotation grub screw. What I want to do is to make this quarter 28 so it'll be UNF on the new one. I want to do that because it's a finer thread, and therefore I believe that's going to give us less of a stress razor. Not that we're going to have such a directional kind of issue as we would have in a sand casting like this with the continuous cast iron, but I think it's prudent and it's a good design modification to do. So we're going to make this hole 5.5 when we drill it, and we'll put a quarter 28 UNF thread into that as opposed to quarter 20 UNC. 5.5 millimeters is the nearest metric tapping drill size. It's 7/32 I think for a quarter 28. So that's what we're going to do. So without further ado, we'll get over to the mill drill now and we'll start preparing to put these holes in. So this is the setup that we're going to use to drill the holes in the nut housing. This is my Arduino driven vertex rotary table. So I made a video about this about 6 months ago now, and it might be worth going back to look at that if you've not seen it, because I go through how I built this and how it all works and how I put the stepper motor on it here. So it's got this adapter plate on the rotary table. I had to drill extra holes in this because the holes in the adapter plate originally were at 90 degree divisions, so there's 4 of them, whereas I had 120 degree slots in the table, so I had to drill 3 more holes in this adapter plate. And this chuck is sitting on top of here on a register, but because you get some inaccuracy from the chuck, I've put the bore of the nut housing is held on the bore by the internal. The external portion of the 3-jaw chuck jaws are on the internal bore, and then I've centered everything by using the clock on the internal bore of the nut housing, so that the bore of the nut housing is dead on the axis of the rotary table, and then I'll move the chuck over on the machine so that then the chuck centered, or the spindle of the machine is centered over the axis of the rotary table, and everything is then coaxial. So I'll bring the camera around now and I'll show you the clock gauge so you can see that we're pretty much bang on. Now this clock gauge is a 0.01 millimeter, which is about, what's that, about 4/10 of a thou. So you'll see that in a second. I'll bring you around and I'll just show you this, the control box. I don't know if you can see that, it might not show up very well, but the mode is set to run, which means that when I press the button to operate the stepper motor, the rotary table will just spin continuously until I press the button again to tell it to stop. So we can see that that we're nicely centered up. So I'll show you that now. So I'll show you now the concentricity of everything that's mounted on the table. So you can see here, well, roughly where my finger is, there is where chuck jaw number 3 is. So I'll spin it round until chuck jaw number 3 is back in this location, so we've done a full revolution, and I'll zoom you in now onto the gauge. So you can see the needle there. So let's get this thing running. So I'll do a full revolution, as I say, and we should be within a few tenths, or at least 0.005 mil, which is about 4 tenths. Which is about 2 tenths. So that's just done a full revolution, and you can see that we are indeed within a few tenths concentric. So that's going to be more than good enough for what we're going to be doing. So the next thing we'll do is we'll get the spindle centered over everything else. And it might be reasonable for you to ask at this point, well, where's the nut? Well, the nut's in the freezer, and it has been for about 48 hours. So I'm centering up on this board just now because that's the datum feature for the PCD. Once we've got the PCD in, we'll put the nut in, and then we'll we'll then do the extra holes that we need to do, and we'll just put the drilling for the lubrication fitting. We'll just go straight through the nut, and then we'll put the 1/4 UNF grub screw in, as I mentioned earlier. That's going to be the anti-rotation feature. Okay, so I've got the machine spindle lined up over the top of the rotary table and the component now. Everything's coaxial to within, I would say, at least 5 tenths. I'm actually now got to the point where I'm inside the envelope of the chuck run out. So it's not looking too bad at the moment. It's pretty good actually. So, and yes, I know I really do need to either make or obtain a better way of doing this. But this has worked anyway, without too much faff. So what we'll do next is we'll move the chuck over the requisite amount to get us onto our PCD. So the PCD was 3.625, if you'll remember. We went into that in some detail on the whiteboard. So 1.8125 is the radius that we'll have to move the machine spindle over. And now this is a metric machine, so that comes to 46.03 millimeters. Will give us 3.625, or within a couple of tenths anyway of that figure. So we'll do that now. We'll get a drill up and we'll start putting these holes in. Okay, so we're just about ready to start now. Just bear with me as I show you what we've got here. So I've just moved it round to position 1. Basically what I've done is, on the Arduino controlled rotary table, I've set up 3 divisions, so each one will be 120 degrees, and we're now in position 1. And yesterday I marked on here, you can see there, I did some rough calculations on the old housing, just to give me some kind of idea as to whether or not I was going to be in the ballpark when I got everything set up for where the PCD is. And if I break down this somewhat ridiculously long center drill that I'm using as a stub drill, you can see that we're pretty much there. I think we're good in terms of being on the PCD. That's just kind of a sanity check from my point of view. I do like to have a bit of a sanity check. So we're in position now. The first thing I'm going to do is, once I've center drilled it, or started it off with the center drill, I've got a 6.4 here that I'm going to put through clearance for 1/4 UNC, and then the head of a 1/4 UNC bolt, if I can pick this one up, is 3/8. So I'm going to use this 10mm spot facing tool to put the spot face in, to put the recess in for the head. So we'll get on and start doing that now. So that's us going through with the clearance drill now. There is no going back. Well, there is, but we won't need to go back. 6.4, as I said, which is a good clearance for 6.35, which is 1/4 inch in metric. Having to swap between metric and imperial quite a lot, because we're working on a metric machine with metric dimensions, and we've got working on an imperial machine with imperial dimensions, I ought to say, and we've got metric machines in the workshop. I can't get my words out today. Right, so we'll get this swarf cleared up, and then we'll get the tool changed over. Just bear with me, you're going to hear the sound of the vacuum. Hope that didn't assail your ears too much. So we'll carry on. I'm going to do all the tool changes for each hole. I'm not going to be messing around doing sort of spinning it around multiple times, indexing it around multiple times. We'll just do each tool change out and produce each hole as we come round. Right, let's see how deep we need to go with this. Let's get this in now. Bit of run out on that, but it's working, it's doing the job. Let's keep going. Right. Let's see where that's at. Switch off the machine, get rid of the stuff. Oh yeah, that's perfect. That's going to be spot on. That's nice. It's not going fully into the hole because of the bottom of the chuck there, but I like it. So let's just see where that's at, depth-wise. Okay. Right, I'll bring you back when we index it round to the next one. So we're moving round to position 2 now. So that has gone round 120. Let's get this drill swapped over again. Look at that, I think that needs demagnetizing. My goodness me. Right, hang on a second, we'll just get that cleared off. Right, I'll bring you back when we're okay, next hole, going through. Get rid of that swarf. Sorry about the sound of the Let's get the spot face up now. It has to be said that these spot faces, well, this one certainly does seem to have a little bit of run out, but it's doing the job, so we'll carry on. Carry on regardless, as they say. Here we go. this to the requisite depth. We'll clear out the swarf. Let's just check that out. I'm thinking actually that one just needs to go a little bit deeper. Not much. See what that's like. Bit of a trial and error thing. This that's better. This Chester mill drill, the sort of the depth setting on it is not the best. Right, let's bring this round to the next division. Okay, let's not. Okay, let's bring it round to the next division now. Yeah, and that looks like they're at 120 degrees, so that's always a bonus, isn't it? So, swap that out. One of the problems with this machine is that the knee is fixed, the table is fixed, so you can't wind the knee up and down. So you end up in situations where the spindle is quite a long way away from the work in order to get clearance between the chuck and the workpiece. So that's why I've got this thing. It's quite handy, and it's actually, some of the stub drills I've got are too short as well sometimes to do this type of work, so this long centre drill, although it's not the best in the world, is actually quite useful for things like this. It's about the only thing I do use it for, actually. One of the reasons I need to get the Harrison mill working actually is to have a decent milling capacity. This thing served me well for many years, and it's serving me well now in repairing and refurbishing the Harrison mill, but it does have its limitations, which, to be fair, I have learnt to work well within. And I think working within your limitations is always a good trait. You're going to get sick of the sound of that vac, aren't you, by the time this is done? Right. Let's get the 6.4 up now. Okay. We're good. Let's go. That wasn't very good, was it? I think we might have got away with it. That just move in there, I think it might have done, but I think we'll be alright. I'll bring you back once I've checked this and made sure everything's okay. I think we're going to be okay. So I've checked me chuck. Hey up, chuck. And everything's okay. Just a bit of a bump as we went through. Everything's lined up well, so off we go again with the spot face. see what that's like. Apologies for the Hoover again. Bit more. Quite a lot more actually. Like. Yeah, that's spot on. That will do for B. Yeah. Okay, so we now have 3 holes on a PCD, and let me show you those holes. Let's watch it gently rotate, why don't we? Let's get into the correct mode first, and we'll watch it gently rotate. And you can see those lovely 3 holes at 120. Round and round and round it goes. Where it stops, nobody knows. Well, that's not strictly true, I know. What a beauty. Well, I won't go that far, but it'll certainly do the job. So what I think we'll do now is, once I've stood here and admired it for a few minutes, is I'll take it over to the machine and make sure that these indeed do line up with the holes on the machine, because we could be doing all this again. But I don't think we will be, so we should be okay. So here's quite a nice sight. It fits, you know, which I'm always happy about. Which it's never wholly guaranteed, is it? But yeah, so according to all the work we did measuring and the calculations and everything else, it goes on and it's a nice fit. There isn't a bolt in this one, because when I took the old one off, I sheared that bolt off and I still haven't removed it. But fortunately there is a stub sticking up, so the hole is sitting over the stub, and then these 2 bolts are fitted quite nicely. So yeah, that looks quite nice in there, doesn't it? It'll be even nicer when it's got the nut in and it's painted up. So our next task is to warm this up, because as I said before, the nut's in the freezer and has been for about 48 hours. So we'll heat this up now, just with a heat gun. I don't have anything, any sort of oxypropane or anything like that to heat it up with. So we'll just use a heat gun, and then we'll marry the nut and the housing together, and that should be them together till death do their part. So we're not in the workshop. We're in my house. In fact, we're in my kitchen. And I'm not going to be like a certain YouTube machinist who has started making cooking videos. But let's just put it this way. This did not happen, and I was never here. Okay, so this is it. Take your seats for the society wedding of the decade. So the nut has come out of the freezer and it's very cold. It's about -18. I'm not exactly sure what temperature is, but enough that my fingers stick to it if I don't wear gloves, let's put it that way. And the housing has just come out from the unspecified place where it's been warmed up, and it's sitting at about 200 degrees Celsius. So we'll get the camera set up now so you can see these 2 being put together. Right. Just bear with me while I put the glove on, and let's give this a go, because I'm confident that that's just going to go in. Right, I like it. I like it a lot. That's definitely in there. So what we're going to do now is leave everything to come up to room temperature, and we'll come back once the thing has equalized and attained normal temperature. Now I've got to try and take the glove off to switch the camera off. Very happy with the way that went together. So set the rotary table up at 90 degrees to its previous orientation, but I've been having real problems with this little chuck. I've been trying to put the reverse jaws onto it to hold the part for us to drill the holes that we need to for the anti-rotation grub screw and the lubrication fitting, but I assumed wrongly that this chuck would be okay to use. It came as part of a kit from Vertex to add a chuck to the rotary table. It needs a good strip down and a deburr and a clean up. I'm really struggling to get the reverse jaws and just the normal jaws on at the moment. So I don't have enough time now because I've got to go back to work tomorrow evening, so I just don't have the time to strip this chuck down, get it all sorted out, nor do I have the time to remove it from the rotary table and set the component up on the rotary table without a chuck. I wouldn't have enough time if I did all that to actually produce a result that I'd be happy with or that I'd be proud of. I'd just end up rushing it and probably making a mistake and making a mess of it, which I really don't want to do. So I'm just going to put this video out as it is now, and you'll be able to see how I drilled the holes. Okay people, so that's the end of that. As I said just now, I'm going to call it at this point because I don't really have enough time to carry on. I don't really want to make a mess of the component by trying to rush it to get it finished for the video. So here it is. We've managed to marry up the nut with the cast iron housing, and that's going absolutely nowhere. That's solid in there now. This is cooled down to normal temperature now, and so we've got our three 120 degree spaced holes in it as well on the PCD, the 3.625. So that's looking really nice. I'm really happy with this. The next thing to do, as you know, is to put the holes in 90 degree opposed holes, one for the anti-rotation grub screw, quarter UNF that we're going to go to, as we said, and also for the lubrication fitting, which oddly enough is also quarter UNF as well. So that's the end of the video. I'm away to work tomorrow evening, so I won't be around for a while, about 4 weeks. So I'll see you when I get back. I just want to make a shout out actually to a gentleman whose videos I watch quite a lot, a man called Phil Whitley. Now Phil has an excellent channel called My Week This Week, where he goes and shows us all the things he's been getting up to in his workshop, and also doing lots of different jobs outside on his friend's smallholding, building fences, clearing the garden out. He's also got a nice, I believe it's a Fordson tractor that he's done up, and he's been repairing some hydraulic leaks on it. And in addition to that, he has a really nice lathe refurbishment project. I believe it's a Holbrook lathe that he's rebuilding, so that's excellent as well. And he's a genuinely nice person. He's just a really nice guy, and he's always just a great watch. Just a really genuine person. So I would advise you to get over to his channel and check him out because he's fantastic. So with that, I'd like to say thank you to all the people that are subscribed to me, and to everyone who's come along in the last few weeks. I really do appreciate it, and it makes this all possible for me, and it really does inspire me to carry on and to make better videos. So I'll see you all in a few more weeks, and take care of yourselves.